How? I'm not washing dishes. Nina.
Munyai, can you hear me? Munyai, Rivere. Why first time you were quiet? Why were you quiet at the first time? Okay, let's talk about let's talk about, can you attend on the area where there is a noise? Let's talk about the limits. Let's talk about the limits. Can you see what I'm writing, guys?
Yes.
Okay.
Yeah.
So now, what do you understand about the limits? What do you understand about the limits? So we must use the rule when we're talking about the limits. Let's say we've got the limit of x approaching a. May you please log out and log in? Log out and log in. Right. Okay. I was saying if we've got the limit of any function, let's say we've got the limit of x approaching a. Can you see now? Okay, I was saying if we've got a limit of a function approaching of x approaching a of f at x plus g at x. This is the same as I'm just creating those notes from someone's notes who sent me. So, but this is nothing but equals to our limit is going to multiply each and every function. This is the limit of x approaching a of a function f at x plus the limit of x approaching a of a function g at x. So which means that that limit is going to multiply everything that is inside the what? The brackets. So let's say now we've got the limit of x approaching a of a function f at x minus g at x. So this is nothing but going to be equals to our limit of x approaching a of f at x minus our limit of x approaching a of what we call g at x. So that limit is going to be distributed due to what is inside the brackets. Are you following?
Yes.
Let's say we have the limit of x approaching a of a function f at x multiplied by g at x. So this is the same as the limit of x approaching a of our function f at x multiplied by the limit of x approaching a of our function g at x. And let's proceed. Let's say we've got the limit of x approaching a of a function f at x divided by g at x. So This is the same as that limit is going to be distributed on the numerator. Then it means we've got the limit of x approaching a of f at x divided by the limit of x approaching a of f at x, of g at x. And again, let's say we have the limit of x approaching a of a constant multiplied by a function. So a function, a constant has nothing to do with a limit. So we can place it aside. Then we said we are multiplying it by the limit of x approaching a of that function. And lastly, if I'm not mistaken, let's say we've got the limit of x approaching a of a constant. This is nothing but going to be equals to a constant. So this is where C is a constant. Where C is a constant, and here where our G at H must not be equals to 0. Because if either our G of X is equals to 0, then we will have a problem. Are we good?
Yes.
It simply means that we're going to have a what? A big problem. Can we proceed and do examples?
Yes.
Let's go to examples. They will say evaluate the following limits. In a limit, we can do a direct substitution or we can first simplify it, depend. So if they say evaluate the following, evaluate the following limits. Number one, let's take it easy. Let's say the limit of x approaching 3 of a function 2x squared minus 3x plus 5. Are we still together? So we're going to say this
Yes.
is equals to. Now we are going to use a direct substitution. It means where there is an x, we are going to substitute with the 3. Then this is equals to, and this is 5. The limit of x approaches a constant is a constant. Did you get it? Hello?
Yes.
Then when you press your calculator, everything, what do you get? Why are we doing this? We are avoiding to go like a grade R learners. And then we have already learned the rule to say limit of this first function minus the limit of, no.
We get
There's no marks for this. There's no marks for this. Are we good?
Yeah, we get 14.
We get 14.
Ndichavona ndikanya ndichavona.
Uzama loga out or loga in.
Ndikovoita zvine zvino. Zvifambiso
Ndoshare zvino iko ida. And with that. And then I forget with the banana is the way. But I will also share a recording. Ne?
Okay.
Yeah. So let's say we've got the limit of x approaching -1 of a function 5x cubed minus 2x squared plus x minus 3. So we're going to do a direct substitution. By doing so, we're going to have 5 into what? Where there's a x, we substitute with 3, with -1. Is that so? Then -2 into -1 to the power 2 plus into -1 minus 3. Then when you press your calculator, what do you get?
-11.
-11. Can you see that we're trying to push slowly but surely? Can we proceed? Hello?
Yes.
Yes.
Okay. If I'm saying we've got the limit of x approaching c of x squared plus 2x minus 1. So it means ourselves where there is a x, we're going to put c. It means we're going to have c to the power 2 plus 2c minus 1. Did you see that?
Yes.
Is it difficult?
No.
No.
Okay. So can we go to the next slide?
Yes.
In mathematics, when you're solving, you must be smart. I'm not teaching you how to cram questions. I'm teaching you to know it. Ne? That's why I'm increasing step by step. The limit of x approaches 2 of x squared minus 4 divided by x minus 2. Can you see this limit? Hello? Guys, can you see this limit?
Yes.
On your calculator, when you substitute with the 2 where there's a x, what do you get? What do you get?
Maths error.
You get maths error. So we must avoid that. So we are not going to do a direct substitution, because if we do a direct substitution, we're going to get maths error. So it means this is nothing but going to the equals to, we first simplify. Don't forget to write your equal sign. This is the limit of x approaching 2. And on top, we know that this is nothing but the difference between what? 2 squared. Are we good? Then
Yes.
is x minus 2 and is x plus 2. Then it means here, this one and this one, they are going to cancel. Then we end up with what? With the limit of x approaching 2 of x plus 2. Now, our x can approach 2. It means we're going to have 2 plus 2, and which is equals to 4. Any question?
No question.
And we now proceed.
Yes.
So now, let's say we have this kind of a question. Let's say we've got the limit of x approaches -3 of x squared minus 9 divided by x plus 3. Can you try this one? Can you try this one?
Yes.
Try it. I hope you are done, Mr. Tasson.
Yes.
Was it difficult?
No.
It was not difficult, right?
Yes.
Okay, so what was the solution?
-6.
Okay, it means here we're going to have this is equal to the limit of x approaches -3 and this is x minus 3 and we got x plus 3 and that one and that one they're going to cancel. It means this one and this one they're going to cancel and we are going to have the limit of x approaches -3 with x minus 3 and this is equals to -3 minus 3. Then we get -6. And you see that, to be honest, we can see limit difficult. That's all. Let me do like this. I'm just testing your brain now, né? Or you want me to test it like this? There we go.
We're done.
You are done.
Yeah.
Okay. So what was the solution?
I got 2. I'm not sure about the others, but I got 2.
Then we're going to open 2 brackets, right? Is that so?
Yes.
Then we divide by x minus 1. So we copy everything without an exponent. Then here is our x squared, and here is our positive 1 to the power 2, which is 1. Then this sign must be different with that. If that one is minus, here is plus. Then we multiply the 2. X times 1 is x. Then we cancel those 2. And this is the limit of x approaching 1 of x squared plus x plus 1. Then this is equals to 1 to the power 2 plus 1 plus 1. And this is equals to 3. Are we fine?
Yes.
Can we proceed?
Yes.
Is it difficult?
No.
Let's say we've got the limit of x approaching a constant of x squared plus 4x minus 3, let's say plus 3, divided by x plus 3. Can you try that one? Are you trying?
Yes.
No, I don't understand this one. Can we do correction, please? No, I don't understand it. Please,
Which one?
can we do?
We're done. Can you please do the corrections?
What did you get?
I'm not sure, but I got C+1.
Mm-hmm.
You mean the final answer?
Mm-hmm.
I'm not sure, but I got C+1.
Okay. Then we've got the limit. We're not taking the limit, it approaches, right? We've got the c squared plus 4c plus 3 divided by c plus 3. Are we good?
Yes.
So now we factorize the numerator. Oh, I took time while I was typing the message on the group of. So this is C and C. So we've got 3 and 1. And this is plus, this is plus. Then that one and that one cancel. This one and this one cancel. Then we're left with C plus 1. Did you see it? Was there no question?
Like, Cindy on a final answer C+1, final answer yasho.
Yes.
Okay.
So I took time. I was typing another message.